Hi, today we're going to talk about a hobby project I did to basically identify the ideal combination of GPS satellites that you can use on your watch to record the location accurately. So I think this is useful for my Polar Vantage V watch, but I think several other watches may have a similar setting. Basically, how it looks on the Vantage V is that you can choose 3 different combinations of the satellites. There's Glonass, Galileo, or QZSS. So one thing that this guide doesn't tell you how to choose any of the settings, and today I'm going to tell you a way to accurately with the data to tell that which one works best for your specific location. So let's get started. So first, what we're going to begin with is that we need to create a reference route. So this is our ground truth that tells us against which we will compare all these different combinations of GPS settings. So there are several ways to do it. You can either use an existing GPX track or you can create your own. Both are possible. I would say that creating your own using OSM maps is doable if your track is short enough. So you can essentially narrow down to certain ways inside the OSM file, and you can manually select those ways and for example use OSRM to create a route around those OSM ways. So that's one way, but most commonly you would probably have another GPX recording that would tell you that this is a route you want to use. So one thing you want to do once you have a GPX route is that you want to visualize the reference route. So let's look at that. So here we have a GPX route called Original Route GPX, and it's reasonably good. It doesn't contain a lot of errors. It's fairly noise free, but still there are a few places on the map that are not perfectly aligned to the paths. And since we want to the footpaths, so since we want to have confidence in our measurement, or what we're going to do is run OSRM match service and match the coordinates in this GPX file into the footpaths based on OSM maps. Basically how it's going to work, we will iterate over the coordinates in that GPX file, in the original GPX file, and do a match for each pair of them to the actual footpath. And once we do that, we will see that the matched route it's not very visible here, but one thing that's obvious is that this bridge crossing is much more aligned to the actual bridge versus in the original image. So now you have a reference route. The next step you need to do is basically take this route and use different settings on your watch to record 3 different GPX files. So one GPX file for GLONASS, one for Galileo, one for QZSS. Let's take a look at those. So we will do one thing right away. We will trim the start and stop location to the specified location in our route GPX. This is to make sure, because recording of GPX doesn't exactly stop and start at the same location, and maybe you run in a loop, so you want to take out the specific segment that you want to measure. And the next thing we're going to do, we are going to import the GPX file into PostGIS. So what this does is effectively creates a table with the timestamp and location it reads the GPX file line by line and inserts it into the PostGIS. So I'm running PostGIS locally here with Docker. It's pretty straightforward. So then after you're done with this, you want to calculate the error between the location or GPX file recorded with Glonass Galileo QZSS and your reference route. So the way you would do that is you construct a line string out of the points that you have, and then use the PostGIS st distance function to calculate the distance between the location in the route, the location in your GPX file, and the location in the reference route. So that effectively gives you for each latitude, longitude that you have recorded, how far is that location from the route. And and then you query PostGIS, you save it into the pandas data frame, and this is what you get. So for each satellite, you get this kind of table. All right. So now we can see the visualization for. Now we can see the map for each of the recordings. So the original route that we did with Oyster Match service, the Glonass recording, then the same for Galileo, and the same for QZSS. So actually, even without going into more analysis, you can see visually that Galileo seems to be performing better versus the other two. But let's confirm that. Let's confirm our observation over the whole course. So here we will aggregate. I will get the statistics for each distance to route for each of the data frames for different satellites, and we're gonna plot them together so for us to make it easier to compare. So we can see that roughly the count of points is the same, and we observe that the median error is actually a meter, kind of 5.4 meters on Galileo versus 7 meters for Glonass and 6 for QZSS. So this is pretty obvious. Galileo is doing better. We can also do the plot the location error, so visualize where the error is the biggest, and we can see certain points like here where the route is covered with a rooftop, here where I have deviated from a reference route, so this is an expected error, and we also see here around the tall buildings, and we see a fair amount of error here where the view is blocked by a bridge. Finally, what we can do with this is that we can plot the elevation data. So the source of the truth of elevation data is actually Strava. So Strava activity has this function of correcting the elevation, and it allows us to basically get kind of a reference point for the elevation. So once we have that, we can see that this is the true elevation, which has the route has. It has some more clearer structure, clearer resemblance to the elevation. However, it's also fairly noisy. And QZSS is like that. So based on this, as you can see, Galileo is performing better in my case. I think the results are fairly specific to Singapore, where this recording was made. So obviously you would need to repeat similar setup for your own case to make sure that this is what to make sure that the accuracy is as expected. Hope you find it useful, and this is something that I discovered relatively recently, and I've been using Polar Vantage V with Glonass for several years before I thought that this could be an interesting thing to measure. And of course it requires going back and forth over the same route, over the reference route, at least 3 times. So this is not something I normally do. I don't normally intentionally run the reference routes, but I think the experience was quite interesting.